Okay, so we've made it to Unit 6. Unit 6 is going to be of 4 parts, okay? The reference sheet you'll find under here is a little bit different. This is going to be the final exam reference sheet. I suggest you go ahead and familiarize yourself where everything is. I've kind of kept it in the same format as before. I don't have to pay, it's not back and front on this one. But here's the second page with all this stuff from the units that we did. And then down here at the very bottom, you will see the stuff that we will be using in Unit 6. So I've had a couple of people already ask me if it's going to be just the final exam over Unit 6. By looking at the formula sheet, you can see it's not. 75% of the exam will come from Units 1 through 5. The last unit, Unit 6, will be 25%. I'll go over a little bit more on this information the next time, but you have these formulas for this unit. So in this part, we're going to be talking about sequences and series. Okay, we did a little bit of this in college algebra, and we're going to just go ahead and continue with it. Okay, here we have the write the first 4 terms of the sequence defined by the nth term. So if you remember in college algebra, what we ended up doing was we're saying, hey, if n is equal to 1, all we're going to do is substitute the n for 1 in both of these locations. So here, n is equal to 1, a of 1 is equal to 1 squared plus 5, that's going to be 6. Okay, n is equal to 2, a of 2, 2 squared plus 5, that's 9. N is equal to 3, a of 3, 3 squared plus 5, that's going to be 14. Once you see that you have at least 3, you can kind of see what's happening. You can see that what we're doing here is we're adding 3, and then we're adding 5. So we would assume that the next one will be adding 7. Let's see how that works. N is equal to 4, 4 squared plus 5, and there you go. So you can see kind of the pattern here. All right, and you can see that this is not an arithmetic sequence, and it's not a geometric sequence. We're not multiplying by a common term, and we're not adding by a common difference. Okay, but this is still a sequence. Let's go ahead and do the next one. Okay, same thing, first 4 terms, all we're going to go ahead and do is let a of n equal 1, 2, 3, and 4. So n is equal to 1, a of 1, 3, negative 1/3. Okay, and this is negative 1. We're going to keep doing the same thing. A of 2, 3, negative 1/3 squared. Okay, so make sure you have your parentheses around your negative, because the squared will apply both to the negative sign and the number. Okay, so if you don't do that, you're going to get the incorrect answer. Okay, this means that one of the 3's will cancel out with one of the 3's, letting this be 1/3. Okay, n is equal to 3, a of 3, 3, negative 1/3 cubed. Okay, plug it into the calculator and you will get these values. And we'll go ahead and do one of them as an example. Okay, so here I'm going to go ahead and do 3, negative 1/3 raised to the 3rd. There you go. And then turn it back into a fraction. Negative 1/9. Okay. And then n is equal to 4. A of 4 is equal to 3, negative 1/3 to the 4th power. And here you'll get 1/27. All right. Next part here, number 3. All right, so what it's talking about here is saying write the sequence defined recursively. Okay, so you're going to have some parts on your homework where it's going to ask you to define the equation. Okay, So we're going to go ahead and do that. Let me fix this a little bit. Okay, here we go. All right, so write the first 4 terms of the sequence defined. All right, so this is telling you what the actual first term is. This is also telling you using this specific formula. Okay, so let's start here. A of 1, it's still going to be 3. So what about A of 2? Okay, same thing. All you're doing is plugging a 2 into that negative, into that n right there. Okay, so there's an n and there's an n. So this is the same thing as saying A of 2 is equal to 4A subscript 2 minus 1 minus 2. Okay, this is your subscript. So if I were to subtract these two together, I would have 4. A of 2 minus 1 is 1 minus 2. Well, what does A of 1 mean? A of 1 is the previous term. So we would have 4 times 3 minus 2. And that comes out to 10. 12 minus 2 is 10. So when we do A of 3, we're doing the exact same thing. A of 3 minus 1 minus 2, which is A of 3 minus 1 is A of 2 minus 2. And A of 2 is equal to 10. So I have 4 times 10 minus 2. That would be 38. We're going to do it one more time. A of 4, 4 times A, 4 minus 1, minus 2 is equal to 4 of A of 3 minus 2, which is 4 previous term, 38 minus 2. And here you should get 150. Okay, so when you do the recursive formula, all you're doing is basically using the previous answer to get that current answer. You'll always be given A of 1. All right, let's go ahead and go on. Here's the next one, Fibonacci sequence. This sequence you probably remember or at least heard of it. You have 2 sequences. You add these 2 numbers together, you get a 2. Add the previous 2 terms, 1 plus 2, that's 3. Previous 2, 2 plus 3, that's 5. 5 plus 3 is 8. 8 plus 5 is 13, and so on. Okay? That's one of the most famous sequences that you have here. Okay? We're going to go on to factorial notation. This is a really easy part. This shouldn't cause any problems whatsoever, but I'm going to show you where to get that on your calculator. Okay? So these are called factorials right here. We use factorials a lot when we're doing statistics. It's for permutations and combinations and so forth. What we're going to do is we're just going to show you where it's at. 5 factorial basically means 5 times 4 times 3 times 2 times 1. It's still kind of an expression that's going down. Okay, that's this part right here. Okay, so it's 5 times 4 times 3 times 2 all the way down to 1 if this is the case. The only one that's different is n, is if n is equal to 0. So 0 factorial is always going to be equal to 1. Okay, so let's go ahead and figure out where this is at. I'm going to hit the number 5, and because it's a statistical thing, it's also called probabilities. It would be the PRB button that we've been using for our factors. So I'm going to press PRB. This is permutation, combination, but there's your factorial. It's all related. And there you go. That's all you're doing for these. Okay. All right, let's go ahead and do the rest. Here, I'm going to do, just in the calculator, I'm going to go ahead and do 6 PRB factorial divided by 4 PRB factorial. This will be 30. Okay. When you start seeing these types, you can do it in the calculator just as we've been doing before, but notice that there's 2 numbers here in the denominator. Well, when there's 2 numbers here in the denominator, don't forget your parentheses, order of operations. Okay, let's go ahead and do this one. 9 factorial divided by 4 factorial, oops, went over too much, and I didn't put the parentheses. Insert parentheses times 5 factorial. Okay, and there's your answer, 126. All right, now remember I was saying that they're very similar to permutation and combination. Well, I'm going to show you just another way that you can look at this one here. Okay, so this is actually, and I'm going to just show you a little bit of a trick. When you have a number 9 up here and you have two numbers in the denominator, as long as these two add up to 9, 4 plus 5 is 9, then we can say that this is going to be a combination. So I'm going to start with the number 9, go to that PRB, and then I'm going to combination. Now, you can use the 4 or you can use the 5. Honestly, it doesn't matter. You're still going to get the exact same answer. Okay? So I use the 4 in this case. I'm going to change this to a 5. And you see you get the exact same answer. Okay? You don't have to know that, but if you did take a statistics class, you'll probably remember this from that. All right? Sometimes, however, you're not going to have that luxury of having numbers. You're just going to have letters. So I'm going to go ahead and show you how to do these. Slightly different here. Remember, n is going to be n times n minus 1 times n minus 2 all the way to 1. Okay, all the way to 1. This one starts at n minus 1 times n minus 2 all the way to 1. So these will essentially cancel out. Everything in between, just leaving an n. Okay, just leaving an n. All right, number 8. Here we go. Give a sequence defined by this, a of 3. Notice here it's specifically asking n to be equal to 3. I'm going to go ahead and put here. Therefore, n is equal to 3 because of that little subscript there. So all I'm going to do is say a of 3 is equal to 3 times 3 factorial divided by 3 cubed. Okay, this is going to be 9 factorial divided by 3 times 3 is 9. 9 times 3 is 27. Okay, so I'm just going to use the calculator for that. So 9 factorial divided by 27. There you go. 13440. Okay, that's it. This should be a fairly easy homework assignment with everything that we're doing. All right, let's go ahead and look at the summation notation. Okay, we have some of these on here, especially for the first part where you're going to have this type of notation. It's going to be really important that you know what this means, because it's going to be kind of difficult to tell when we have more than one. You have to really actually learn how to read it. So I'm going to go over that real quick with you, and then we'll do some examples. The summation notation. Anytime you see this symbol, it's just saying, hey, if we were to find the sequence from the starting value of whatever's at the subscript, the lower limit, which is like a 1, a 2, a 3. This depends on where you want to start, to your upper limit. What happens if we add them all up? Okay, that's going to be our notation. Okay. So if we wanted to know all the terms from an infinite series, we would just use, well, what's the notation of the summation from 1 to infinity? That means we're going through all of the specific terms. All right. So, and notice here it just has that dot, dot, dot. All right. So let's go ahead and start with number 9. So number 9 states we're starting at 1 and we're going to 3. So we're going to write, and it's summation, so we're adding these terms together. So let's go ahead and do that. Okay, so 3, k has to be equal to 1, so I'm going to use 1 minus 8. Okay, this is going to be our first term. We just plug in a 1. Here I'm going to put up here k is equal to 1. Plus, remember the summation means adding. Then we're going to let k equals to 2. We're going to let k equals to 2. So here would be 3 times 2 minus 8 plus, keep going, we have to go up to 3. We include 3. K is equal to 3. 3 times 3 minus 8. Okay, let's go ahead and figure all this out. 3 minus 8, well, that's negative 5. Plus 6 minus 8, that's negative 2. Plus 9 minus 8, that's going to be 1. And then we're going to say negative 7 plus 1, that comes out to negative 6. So our first answer is just going to be negative 6. Okay, when we add up all those individual terms, we get a negative 6. Okay. For number 10, we're going to start with k is equal to 1, and we're going to do 4 terms. So let's start. K is equal to 1. 2 times 1, 1 squared. Plus, I'm not going to write the k's every single time. 2 times 2 over 2 squared. Plus 2 times 3, 3 squared. Plus 2 times 4 over 4 squared. Okay? All right? Once we do all of this, I would just suggest using your calculator. Okay? So I'm going to go ahead and do some of this by hand. 2 is here. Plus, this is going to be 4 divided by 4. That's 1. Okay? Plus 6 over 9. That's the same thing as 2/3, but I'll leave it like that for now. Plus 8 over 16. Okay, so let's go ahead and figure that out in the calculator. Well, definitely 3 plus, this is the same thing as 2/3, plus this is the same thing as 1/2. So I add everything in there and we get 25 over 6. So here my answer is going to be 25 over 6. Okay, that's answer number 2. All right. How about number 11? We're going to do the same thing, but notice here on this case we're not starting at 1. We're actually starting at j is equal to 3. And in fact here I noticed that this is a yeah, that's actually a k. No, this is actually an I, so I should have used an I here for your subscript. These little letters are really hard to tell, but here's a j, so we're starting at j is equal to 3. And all you're going to do is substitute wherever you see a j, you're going to substitute it with a 3. So here I'm going to go ahead and start with the first one. Negative 1. 3 plus 1 is 4. 3 times 3. That's our first term. Plus, we're going to do it for 4. Negative 1. 4 plus 1, that's 5. Times 3 times 4. That's our second term. Plus, negative 1. 5 plus 1 is 6. Times 3 times 5. And that's our third term. Okay, so all I did was plug in a 3 here. That came out to 4, 5, and 6. And then I left the j what it was. So this was 3, 4, and 5. Okay, that's all you do. Use the calculator to go ahead and simplify this just for the sake of time. I'm going to go ahead and just write down the answer here. This comes out to, you should get 12. Okay, this is going to be our next answer. Okay. All right, let's go ahead and go down here. Now notice in this case it says n is equal to 1 and it goes to 4, but there's no n anywhere on this constant. Well, that's because all you're doing is adding 10 4 times. Okay, that's all you're doing. Here this is like n is equal to 1, n is equal to 2, n is equal to 3, and n is equal to 4. But since we don't have an n in the actual equation here, or this part of the index here, or part of the number here, you're just repeating the 10 consistently 4 times.